Welcome to the 2021 Wilmington Spring Workshop.
So my first talk, I'm going to be doing two talks. The first one's going to cover some slides that I've presented before, but they've been updated a little bit, and it's also a good refresher, just some recent marine items, and also get into probabilistic winds and how they can be used for DSS purposes and for hazard decision making. So we'll go through motivation for three topics of this presentation. First is wave height obs and verification grids, and the main theme behind that is we have a lot of ways to look at buoy observations. We can look at OBS monitor, AWIPS text files, NDBC, a whole slew of ways to look at things, but there's really no good way to directly incorporate that into our forecast, and that was sort of the goal with all this, especially on an aerial map. In terms of creating a wave height loader procedure, that was due to the fact that populating wave height grids is really cumbersome because a lot of people are just clicking hour by hour and just model blending in different blends of models. So you also have varying model temporal resolutions, especially out in time where you only get 6-hour grids for the WNA wave 4, but you get hourly for the NWPS the whole 144 hours. So post-editing is necessary too with some of this stuff. And finally, with probabilistic winds, the main motivation behind that is simply just that conveying forecast uncertainty and a range of possibilities will provide valuable information to our public and core customers. So the goals, first of all, for the wave height obs and verification, we have the buoy observations automatically being populated in the GFB over the last hour. And then these values are compared to the model values for the NWPS, NBM, and the WNA wave 4 to track performance and also create bias corrections off of that factor into a local ILM blend. The goal behind the wave height loader procedure was just simply to have a procedure that can easily populate wave heights for various time frames, and at the same time give you some options, some customizing ability, but not anything too complex or confusing. Probabilistic winds, the goal is just to incorporate all the model guidance we have available, whether it's near-term, short-term, or long-term guidance, to create several different wind probability grids, gust probabilities as well, and mainly focus these around the marine and land hazard criteria. Land hazard being wind advisory and high wind warning, and marine criteria obviously being small craft, gale, and storm force. So this is an element group. I use this every 3 hours when I'm doing my wave height forecast. So if you go to wave height in all caps, it shows our observations under wave height obs, and then it uses verification grids below. There was one against our forecast, NWPS, NBM, WNA wave 4. And then also an ILM blend verification grid, which is usually close to 0 because it's already factoring in all the biases talked about before. So how do the observations get pulled into GFB? Well, I'm pulling them directly from the AWIPS text files on a cron, and I circle them onto a grid box. And then finally, I enlarge it for easier viewing, because otherwise it would just be one small little pixel in 6 different spots and really tough to read. So the colors are a little more pronounced by expanding it. And for the time being, 4119 and 41004 are down, but the other 4 sites are still working at the moment. Hopefully those other 2 sites come back up later this spring or this summer. So you might ask why I'm sort of using this backhand method with wave height obs instead of the Weather Service IRMA, where there's a couple issues with IRMA. The biggest thing to me is that the values don't always match the actual ground truth. I know there's been a lot of discussion about this, how the temperatures, it could be averaged over the 2.5 degree pixel. So whatever the ASOS is showing doesn't have to be what the IRMA is showing there. And that, I mean, argument could be made for that. But something like wave heights, where you don't really have a lot of guidance sources, initializations, and observations to begin with, to me, the IRMA should always be matching what the buoy observations are showing, and we don't see that. In this example below, you have 4 observations that are off from what the IRMA is showing. Also, the IRMA is 6 hours old at all times, and the wave height obs are updated every hour. So if we're doing any kind of real-time bias correction with verification, the 6 hour old would be a major problem. We want something current to the current hours, and that's what we're getting with wave height obs. Also of note, with this, there's definitely a marine mask filling issue with the MBM. Unlike the WNA Wave 4 and the NWPS, the MBM just has a coarse initialization grid. It gets worse over time, but if you were to load MBM directly into your forecast grids, a mariner could click on a point-and-click forecast, say right off Wrightsville Beach, and it would say seas 1 foot or less. Even if we had a hurricane and we had 10-foot seas out there, it'd say seas 1 foot or less. And the same would hold true for the hourly weather graph. It would just be showing 0 feet. So this is just something to keep in mind. And I do have a fill routine run on the MBM guidance in a separate database for incorporation with the ILM blend that we use. But then again, if you're just loading in raw NBM, it's going to have these missing gaps along the coast. So I don't have a time frame on when this is going to be fixed. I sent emails about this about 18 months ago, and it still hasn't been addressed. So hopefully at some point it can be looked into, because I know it's happening at other offices up the coast as well. And this is another example of the MBM in the extended. This is a more extreme example where you actually have almost half the zone with 0 foot wave heights, which would obviously be major issues for a point-and-click marine forecast, but even a CWF, because it'd be averaging in all those zeros to skew your average really down. So just be careful with using this data. So the wave height verification grids just use a warm-cool color curve. If you look at each individual one, this is for the WNA Wave 4. You see a lot of cool colors, so the forecast is running too low. Now, I have a bias correction built in to account for this in the ILM blend, but in general, if you didn't want to use that, you might want to just favor a different guidance source simply, like the NWPS, because obviously the WNA Wave 4 is kind of out to lunch here, and it's this low right now, 2 to 3 feet. It's probably going to be like that for the remainder of the first period forecast. So this is a snapshot of our verification. This is over a 365-day period, so it's a very large sample set for our buoys using the wave height obs, and it shows, at least over the very near term, at 3 hours even, almost a 50% reduction in error with the ILM blend versus the NWPS and the MBM. And as expected over time, everything kind of narrows together. One thing that stays the same, though, is you can see that WNA Wave 4 does not perform particularly well. And for the most part, the ILM blend does the best in the extended, but there are a couple times here or there, I think 1 or 2 times where the NBM and the NWPS perform better. And a lot of this has to do with how I had too much WNA Wave 4 blended into the ILM blend. So I've made some adjustments since then, and that's sort of the point of doing this verification too, because adjustments can be made after the fact. And I'm also putting into place some long-term bias corrections that weren't in there before. So hopefully when the verification is run again, we continue to see the numbers go down. So future work, I'd like to study the model performance during various weather patterns and wind directions. I'll give an example, like with this new NWPS data, if it's picking up on some high period surf, that has a tendency to maybe raise wave heights, especially near the coast. I can account for that in some sort of bias correction. Also the time of year, a lot of times when we have a northeast swell event, the models tend to underdo forecasted waves. So things like that could be added to the real-time bias corrections already in place. So the idea is to have something ready to go that the forecaster doesn't have to spend a lot of time with making hand edits here and there over and over again. And since we have a really simple coastal waters compared to a lot of other offices, this is a little easier to do. So the wave height loader procedure allows you to do the entire wave height forecast in one GUI, and you can select different time periods, models, and make some pretty minor but efficient post edits. The defaults shown below are good starting points to work off of. On the left, there's options to run it for your shift. For instance, I use through period 3. I'm going to do that this afternoon for my 8 shift. You can choose your model. Also, you can adjust the output. So say you have wave heights that you don't think they're getting close enough to the coast or they're not high enough. You could just add 1 foot simply there for your selected time range. And then in addition to that, if you think, say your 3-foot waves are making it all the way to the coast, but you don't like how you have a lot of 1 to 2 foot pixels right at the coast, you could just simply do no lower than 3 feet there. So the defaults in here should work most of the time, but if you wanted to blend the official forecast as well, and that's the last area on the right, you can incorporate the previous official forecast by blending it with this new output. So some best practices, I already went through a lot of these things. I'm not going to spend too much time. Just utilize that wave height element group. Make some GUI selections if things seem awry or you want to make a change if the guidance is verifying quite poorly or it's not bringing high seas close enough to the coast. And the other thing is you don't have to use the wave height loader procedure. If you're doing a near-term update and you click wave heights for that checkbox, it's going to use wave height loader defaults. So it's just another way to get the job done. So finally, last part of this is probabilistic winds. And these are created using all the guidance available, creating a probability density function and just performing some calculus in the background. And it's available in the wind probability weather element group. I use it often to decide on start and end times for hazards. I try to key in on what's in our marine best practices guide, about 15 to 30% of the zone meeting criteria for at least 3 hours. So there's thresholds down there, sustained winds, wind gusts, a small craft advisory, gale, and storm. And then also percentiles that are useful. There's a 10th percentile, 50th, and 90th percentile. 10th percentile would be the best case scenario if someone asks you the best case. And then reasonable worst case scenario would be the 90th percentile. So in this grid here is a probability wind 25 knots grid. Example showing that small craft advisory winds are almost definite because you have 100% over a large part of the zone in terms of our coastal water zones. And I think this stuff's going to be even more useful when we go to out 60 nautical miles because obviously this is running out there and a lot of the guidance is going to extend that far out. Here's a probability wind gust 34 knot grid. Example here shows that wind gusts to gale force are unlikely because I don't really see that many high percentages within the 20 nautical mile zone, just maybe some fringes of 10 to 30%. And temporally, it's not even going to last that long. It's just 1 to 2 hours. But something like this would support just a small craft advisory, not a gale. So reasonable worst case scenario here for gusts close to gale because it's the wind gust 90 percentile grid. In other words, that would be a 10% chance of reaching gale gusts because we have right around 34 knots showing in this grid for the coastal waters. So there's a lot of different ways that these grids can be utilized. And also there's criteria now for wind advisory over land and high wind warning as well. So a couple of potential VSS uses. If you had a question over the phone from a core partner, they might ask, for instance, what is the chance of gale force gusts behind the cold front 3 miles offshore of Cape Fear? Well, you can just simply utilize the probability wind gust 34 knot grids. That will give you a good idea what to say. Also, what are the highest wind gusts possible in Myrtle Beach with this system? We have the wind gust 90 percentile grids, which gives a reasonable worst case scenario, which is something I'd probably want to show if I'm asked what is the highest possible. Any comments or questions on this presentation?
Yeah, Matt, this is Reed. When you do your ILM blend, do you incorporate the previous forecast, official forecast in that, or no?
No, it's just the
Okay.
it's just the MBM. Yeah, it's just the models and the it's just the model. But I do incorporate previous model runs. So I'll give you an example. If the WNA wave 4 just started coming in and some of the grids are missing, I do utilize the previous run, but I don't use the previous forecast now.
Okay, thanks. One other point on the MBM. Just to let everybody know, there's not going to be any updates or changes because they're getting into the moratorium for putting in the new supercomputer. So most operational things are not going to be, well, all operational things are not going to be updated for almost 18 months because of the new supercomputer.
Yeah, I
That's
think
all.
it's like January 2023.
Yeah,
So
it's crazy.
it's a long time, yeah. So I was hoping that some of the stuff would get in there before, but unfortunately it didn't make it. So we'll just have to work with what we have for now. So, but thanks for the questions. Anything
Matt, I have
else?
a comment.
Yeah.
It's Rachel. I know
Yeah.
that the wave height loader, I'm not sure if people do it. I think some people run it just when the model is run, this new SWAN data or WNA comes in. I'm
Yeah.
just a comment. I think it's good to run whenever you do the near term because you have all the observations built in.
It's set up that you can run. It's set up that you can run it any minute of the day. I mean, it's always gonna. There's always gonna be data available. If you wait till the NWPS comes in, you could run it after it comes in. Otherwise, that ILM blend is running on a cron every 15 minutes the whole day, so it doesn't make a difference if you run it. If you do want to use NWPS, like you said, yeah, I agree. You probably have to wait till we get the banner that it's all in. But otherwise, yeah, I mean, it's always using the latest data available when it updates every 15 minutes.
Yeah, that's what my comment is, that people should probably utilize it more than just when the model comes in. I'm not sure if people do, but I think many people probably just run it when the model data comes in.
Yeah, that's a good point. I mean, I've always encouraged on the ops floor to run it. I mean, I run it every 3 hours, even if I think my forecast looks fine. I mean, the bias corrections are updating every hour, so I'll just update the near term every 3 hours with the data. And I mean, it takes 2 seconds to run that procedure, so I don't think it's a workload issue. It's just going to get us an updated forecast out. But that's sort of forecaster discretion to some extent. But in general, the more you run it, the better, because the bias correction is always being updated every hour. So, but thanks for the point.
Hey, Matt, it's Tim. UNCW recently added 2 new wave rider buoys, one about a half-mile east of Masonboro Island, the other a half-mile east of Bald Head Island, and those could be used also in some of your grids there to update observations.
Okay, are they on NDBC?
As far as I know, they're not. I pull off the SST data through the Corp site to go in the Mesonet, but I could certainly get the wave height data also, put it in a text file somewhere for you.
Yeah, because if it's in, I mean, it doesn't have to be the OSO, but if it's in any kind of text file, I could pull it. Because, yeah, we just have some, like some of these outages last a long time. Like 41004 has been down for a long time. So it'd always be helpful to get some more observations in there. So thanks for pointing that out.
Yeah, I'll send you the information tonight when I'm back at work.
Okay, thanks.
Hey, Matt, just a comment on the wind probabilities. You know, you brought up a really good point about the DSS component of that. I think that there's probably also an opportunity for our office to be proactive with those probabilities. And, you know, to me, that's like really good information to mention in AFDs and potentially briefings of just the probabilities for those important thresholds that mariners are making decisions off of. So I would encourage our office to think proactively with how to get that information out in some of the communication we have, you know, and not necessarily need to wait for questions to come in, because this is really powerful stuff and is to get in.
Yeah, and I mean, we could even potentially do some kind of graph. I mean, this could be used as a social media post if you think about it, or a briefing image, or a social media post if we use graph IDSS and make sure the color curves look decent. I think that's feasible.